Hello, welcome to our webinar from September. We are glad you're here. This is my friend Jaime.
Hey.
And I'm Jan Visser. So I don't know if your sound is alright and your video is alright. I hope it is. What we'll be doing today, Jaime.
Yay.
Where is our mouse?
Right here. You can hit now. Hey.
Oh, we passed one. Well, as you can see, I'm Jan Visser. Next to me is Jaime.
Jaime. Hey.
And today we are discussing soldering, questions about soldering in general, answers for these questions. Well, let's see what we got on soldering.
Yeah, actually we got a lot of questions from people, so
Yeah.
that's nice, and yeah, I mean really interesting. You know, different levels. So for experienced people and beginners, so it's gonna be cool. Yeah.
Well, it looked to me the best thing to do is to tell something in general about, and then see if we already can solve some issues, and then we go to the questions to answer them, to discuss about that. Okay, what is soldering? It's just connecting two metal items by melting a filler metal into this joint, as you can see here on this illustration. And that's the only thing there is. That's soldering. That's the difference between soldering and welding. Welding, you have a melting bath, and with soldering you just have two materials, they don't melt. You have a filler metal in it. So that's one. Of course there are different kinds of soldering, and we like to focus now on the things that we do in electronics, and that is hand soldering, and that is again divided in contact soldering or non-contact soldering. And then, of course, the contact soldering is done by the soldering iron.
Old school.
Old school, yeah. Some call it old school. The non-contact is done by the hot air gun or an SMD oven. So that are a few different kinds of soldering. We also have the machine soldering, because we also had some questions about machine soldering.
Because it's probably the most, I mean, like do-it-yourself soldering is everybody can do that at home, but the machine soldering is another story, and it's big productions.
Yeah, machine soldering is another story. Also, this happens contact or non-contact. The contact is wave soldering. The non-contact is a reflow oven or machine. But there's also more than wave soldering, because there's a dip soldering process, which we also have questions about. I'll be explaining that later. And today there are also robot soldering machines.
Yeah, you mean pick and place?
Not only pick and place, but also the machines the robot machines can solder it. So that's it looks very nice if you see it. It looks very nice.
Really fast and efficient.
Yeah.
Okay.
Okay, so today's focus will be on contact soldering, and especially on manual soldering, but we'll also discussing some machine techniques.
Perfect.
We had in our box we had some questions about solders and all different kind of solder wires that are mixtures of all these kinds. And the most common that we use, I have here all kinds of different solder wires.
Oh yeah, you brought some stuff with you. That's
this is only what we have here in our house. So it's not all the stuff that there is, but there's a lot of it. There are more than 40-50 different solder wires to choose from. So I'll lay them on the side so you can maybe see what's on it.
Yeah, I'm sure that we can zoom in exactly like that. Maybe. Yeah, okay.
And as you can see, there's a number on it, and there are several numbers on it. There is SN and PB, letters on it, numbers on it. Yes, that's one. On this one is SNAG CUO. and this means, as I'm right, there's silver in it, there's copper in it,
Yep.
and
tin.
and tin also. Yeah.
Mhm.
The most common we use is well, are these four, the four of these. If we can divide this is a lead-free.
Yeah.
This is a lead-free.
Lead-free as well.
This is a leaded version. This is a leaded version, and this is a leaded version.
Mhm.
So we have two kinds of versions that are leaded, these two, and we have three kinds of leaded, non-leaded.
Yeah, like environmentally friendly.
Yeah.
So.
Yeah.
Mhm.
The lead, these ones are common lead, and that means they're 60-40. That means they have 60% tin and 40% of lead in it. The melting point of these is round about 180 degrees Celsius, and you can put the tip, because the heating transfer you have to do. You can put the tip of the soldering iron. The tip of the soldering iron can be at 290 degrees Celsius. So that's for one. For the other one, it's a slightly different story. People always ask us when we are on events, what do you use and why is it so sometimes difficult to solder some things? It didn't used to be difficult. That means they are now buying the lead-free stuff. That means that you have to make a few arrangements in your setting. You have to put up your tip temperature to somewhere between 310 320 degrees. Because the melting temperature, since there is no lead involved, because it's not environmentally friendly, the temperature has to go up to make the mixture melt. So it means these commonly used non-leaded are 99.3% tin and 0.7% copper. The melting temperature, as you can see, is almost, I looked it up for this one because it depends on various mixtures. And it's 230 degrees for these. So that doesn't mean that at home you will have the same melting temperature, or you can use the same tip temperature, but it's a start. First, you have to look at what's on your
yeah, I mean the composition of the
composition. Yeah, and then you can look it up. There are tables for this. So I looked this up, so I know it. And then, well, it melts at 230 degrees. That means that it's almost 40 degrees higher than a normal leaded version. You have to put the tip at 315 degrees. Also, it depends on how big is your tip. How much power does your
soldering station
takes. So that's one of these. So we have, in generally, these are the two that we are working with. We had a question from Mr. Royakkers. Whilst lead is forbidden nowadays, there are all kinds of mixture used in solder today. Why? And well, lead is forbidden because it's environmentally not friendly. With the production of large quantities of PCBs, and we are all using more and more electronics, because electronics is in everything. So with the production of telephones, televisions, cameras,
any household device.
Every household device is electronics involved. With the production and in production process, there's a huge amount of lead coming into the environment, and we don't want that to happen. So that means we don't use lead for production process. On the other hand, for repairs and rework, it's accepted because there are much smaller amounts. I mean, how much do you use at home? If you have a roll of solder like this, I think at home you'll do 1 year with it. So the amount of pollution in the environment is relatively.
You mean the impact you're causing or something? So for the people who is watching us, I mean, they can safely use this one.
If they're not in the production process and melting down kilos from this stuff,
Yeah,
then it's
do
alright.
that.
Yeah, it's alright to do so.
Although it's fun because
To melt a few kilos,
yeah. Exactly.
it will cost you a lot.
Yeah.
It's not cheap. So, to get back to the questions, all kinds of mixtures, and I have. It all depends on the solid state and the liquid state of the mixture that you have, and the melting point is influenced by every metal you put in. There's tin in it, you can have lead in it, you can have copper in it, silver, brass, zinc, bismuth, indium, antimony, alu. So all kinds of mixtures are possible, and every production plant wants to have their own
custom alloy.
Alloy, yeah, their own custom mixture. So that's why you can almost order it in every mixer that you want. If you are
Making a big production,
we can, because we are only having small amounts. So maybe every designer that works here uses 2 of these each year or so. So it's not that big. So it's for repairs. It's still it's the easiest way to do. If you get good results with lead-free, then please use lead-free, because that will be in the end environmentally friendly. In the end, actually, the leaded will disappear.
Okay, and we've been discussing also that because I don't see gold in the list, and I know that it is said that satellites are components going in satellites, for example, going to space, they are soldered using gold, and also some really precise connections that you need.
Yes, that's right.
High accuracy.
If you take a look at the price of these devices, then the price of a roll of solder wire with gold in it is relatively small. But if you want to use something with gold in it as big as this at home, you'll be spending a year's salary.
Yeah.
So I don't think it is. It's advisable to use that at home.
Yeah.
If you can get it, that's the point also, because it's very rare. But if someone has a roll of this with gold lying around, please feel free to send it out. We'll test it.
Send samples.
Send samples. Send samples.
Okay, I think we're moving. And sorry. Yay. Okay, so we have second question actually. It comes from Andrew Retalak, and he's saying everything's getting smaller and QFNs are more and more common. I have heard that QFNs are frustrating to reflow solder for the hobbyist due to tombstoning. Would love to hear advice on either reflow or other ways to get these tiny guys stacked down.
Yeah, that can be a pain.
Yeah.
It can be a pain. Also, the QFNs are hard to solder. We are now today we're talking about contact soldering. Yeah. And there is a way to contact solder them. So we'll be discussing next month on the Q&A how to solder them
SMD,
how to solder them contactless with the oven and hot air. Yeah. For now, I'd like to explain to the other attendees what really is tombstoning and how to prevent it. As you can see here, on your right hand, could you give me a...
yes.
Could you give me a pointer?
Of course, it's up here, I think. Laser pointer.
Yes.
There you are. Okay.
I can use this one. Yep. Yes. As you can see here, this is the actual QFN package, and this is what tombstoning is. I tried to find a picture of an actual QFN tombstoning, but I couldn't manage to find one, because everyone keeps it a secret. But tombstoning is actually the not being connected of one point or multiple points, the uprising of the component due to not being able to you have the solder is a different
Yeah,
a
you mean that
temperature.
when the solder of one pad is melting,
Yeah.
it's raising the component.
It's raising the component
Okay.
due to the ball of the
the
soldering.
capillarity, or
Capillarity,
I think
yeah.
it's
And it's the tension of the surface, the surface
surface
tension.
tension.
It puts it up, so it doesn't melt it on.
Mm-hmm.
If you have, for instance, the temperatures not set right, it also happens. You can imagine that if this happens to a QFN, a quad flat package, the N stands for no lead, then you have a problem because it tends to come up, and then you have on one side or on two sides it's soldered, but the other side, the other two sides are not. They're just hanging above. Maybe one or two pads are, but they're just hanging above, and it's a pain in the ass to get them back because you have to do it by hand.
By hand,
Yeah.
And fill the gap with solder, and that's gonna be complicated.
That could be complicated. Yeah. Now the only question you then have, you have to reheat it manually and
press it
on. Yeah.
Huh.
But there's another way to do that, and I'll try to. If you, first I want to explain. If you see here, you have two different kinds of QFN packages. This is a QFN package. This is the top side and this is the bottom side. This is a QFN package that has still some leads popping on the side. There are also a QFN package that don't have leads on the side at all.
Oof.
And this is really, you have to solder that like a BGA, which we also...
So you cannot access the pins from the outside, they are only on the...
If you want to contact solder that, it is possible, but it's only due to capillarity that it could be flowing. You have to use lots of flux to get it right. Here we have the part, the PCB, and it's designed to pick up this QFN. And the best part of it is that there's a hole in it here.
True.
There's a hole in it. And we tend to design QFN packages and QFN PCB design like this because it has a main reason, because you can put the tip of a
your soldering iron,
of a soldering iron at the back of the PCB and solder it there. So that's one side. You could get the QFN on the PCB and then just tape it. That's a trick again. Just tape it on it at the right place with a piece of Kapton tape. This is a piece of Kapton tape. Can you put it here, or should I hold it here?
Yeah.
And the Kapton tape can withstand heat. So if you put this over it, for instance, I have here.
It will not be melting, or... Okay.
Oh, it's, I'm not able to
cut it. Okay.
This is not a QFN package. But
but it works as a example. Yeah.
And then the trick is, if you have the hole on the backside, you can now put it on the table. And take your iron and put it through the hole.
Through the hole.
Then you can solder first solder the top side, and you have this top side soldered. And then it will be stuck.
And then you go pin by pin and...
Nah, it's not quite pin by pin. There's another method. We'll be demonstrating. We'll not be demonstrating it because it's too hard to do it here. But we'll be showing it.
How to do it.
How to do it in the picture.
Alright.
Kapton tape. It's a trick. You can use it also for other packages if you're drag soldering it. So we'll go to the next slide.
Yeah, we have a question from Gonzalo Simos. He wants to know how to solder components to PCBs, and what are the, which kinds of soldering tips are we using normally, or do we have?
Well, how to solder components to PCBs, that is fairly obvious. Just put the components in. We have an example here.
Yeah, with through-hole components.
With through-hole components. That's the easy way to start.
Yeah.
It doesn't look like a guy who's just starting with it, but maybe he is. You try to answer all questions, and then just solder all the leads on this on this PCB. When you make your own PCB, you don't have a screen like this. That's a nice thing that we have on our PCBs. So there's much more risk that you overflow or have some lead on the other pads. But that's if your starter use
through-hole components.
Use through-hole components and use PCB that are that have screen on it, the soldering screen. That means that only the parts that are that you have to solder are left blank. You can solder them, but you cannot solder on the green.
Yeah, because it has silk.
It has a silk screen on it.
Yeah.
So that's for this one. And what are different? What we have different.
Yeah, different tips. I see you're bringing lots of them with you.
We have lots of stuff. Different tips, he asked. I don't think that is enough, because I made a small selection of what we have here, because we have here lots of soldering irons and lots of... one designer likes to use a bended tip like this one, and the other one likes to use a big tip, but also there are all kinds of tips used here. These. I have even more. I don't think that anyone is able to solder down the lab, because there are plenty more standing there.
Now they have to stop. Yeah.
No, they can go on with their work. But this is just the tips that we have lying around to do some stuff, so that we can switch it. And it's nice to switch it. I'll try if I can show that.
Yeah, I think you need the Weller first, or
yeah, this
the
one.
blue one. Yeah, correct.
So for this one is also a different tip. It's a little, it's slightly bended, and you can access better the feet, the pins of the leads. If you look at this, you have a nice angle on it. Yeah, but it depends on what you like. Some designers like to solder with a big tip. Some designers want to solder with a very small tip. Some with a bended, some with a not bended. It all depends. If you want to change this one, you have to screw off this screw. Then you can take it off, take the tip off, put another tip in,
and screw it back.
Screw it back.
Yep.
You have to disconnect this one. You have to disconnect this one. And we experienced in our lab downstairs that you always have to wait a few minutes, because you have to wait because it's hot. It's 200.
So the whole thing is getting really hot.
The whole thing is really hot. Yeah. And therefore there are other methods and other things to do like that. So I have here, and yeah, you cannot see it, but actually this is 290 degrees. This one is 290 degrees. 90 degrees. I can show it to you, because
yeah, perhaps you can solder a component here, whatever.
Here.
Or, yeah.
I think people can see this. It's smoking hot. It's smoking hot. But if I want to, well, I can say I want to have this tip on it, and I just do it like this. Get another tip. This one's not hot, of course. Put it in, and within seconds,
whoa, Yeah, that's fast. That's
That's
really
fast.
fast. That's
Yeah.
way faster than the.
It saves time.
Mhm.
It saves time.
Yeah.
I'll put it back. So we change the tip without waiting for the soldering iron to cool down. And
Mhm.
of course, if you have at home a soldering iron that you have to screw out, you have to wait for it.
Most probably will be this kind, of
Yeah,
course. This
yeah.
small solder. I mean, without the soldering station.
Yeah, don't be in a rush. Just grab a cup of coffee and a
Wait.
piece of cake and wait.
Yeah. Yeah. Let physics do their work.
Yeah, let physics do the works.
And I can see these hot swappable tips you're using.
Yeah.
What happens here? Because I see an electrical contact here, but I mean, is the whole thing getting hot as well, or,
Yes,
or just the tip?
if you look at this one or this one, this is a passive tip,
Mm-hmm.
and it goes in here, and so there's no heating element in here. There is in there.
Mm-hmm.
So you just put out the whole element in this one, and then you swap the whole element.
Mm-hmm.
Of course, these are much more expensive than
Hmm.
these non-active ones.
Yeah, but really convenient.
They are really convenient. Yeah, yeah. We have we have these tips, and we have different kinds of soldering tips, soldering irons. So I think we have another question on that, but we'll come back to that later.
Yeah, enough tips regarding the tips. Okay.
A lot of tips regarding the tips. I just want to show this, maybe this one.
Oh. Hmm.
It's a double one,
Mm-hmm.
and it's used to grab SMD components. If you have an SMD component, you
Yeah,
want
we have
to
whatever.
desolder it.
Oh, we have enough there?
I'll put our our USB board to the test.
Yeah, okay.
And if you want to desolder, you just. It's also contact soldering, so you
So-
just put it on.
So you're melting both.
You're
both
melting
contacts.
both sides, and then if it's hot, this one is not plugged in for your information. But if it's hot on both sides, you just squeeze it a bit and take the component out.
Hmm.
So
So it's like a hybrid between a soldering iron and tweezers.
yeah, it's a hybrid soldering tweezers.
Yeah, yeah, yeah. Alien technology.
Yeah,
Cool, nice.
it's very nice. Yeah. So that's well, all kinds of tips. Don't use just use a tip you're confident with. Don't use a tip that's when you start that is too small, but also don't use a tip that's too large. Don't start with a tip like this, because it's more for if
Really
you-
big stuff.
Yeah,
Mhm.
yeah.
Yeah, actually, the tips that come with the soldering irons that hobbyists are using are
Yeah.
convenient. I mean, are not,
This is a
are
standard
proper, so to say.
standard.
that would be.
Most use we got this for I think it comes with a station for 50 euros or so, and it's a nice tip. It's not too big. It's not too small for doing through hole components. It's in fact to start. It's everything you need.
Good enough.
Yeah.
Okay, then we can move to the next question. And Steve, okay, Steve Drake, he's asking for the goddamn drag method.
The drag
You know,
method.
Yeah,
Yeah.
some great and also, I mean, loved and hated at the same time.
Loved and hated. Yeah, we have
Yeah.
we have a quad flat pack on it.
By the way, this is some cool stuff we will be releasing next month, if I'm not wrong.
Yes.
So it's still unreleased, so you're seeing a premiere.
It's a premiere, yeah.
Premiere.
It's the first time that it's shown to the public. Yeah.
Okay.
And this one is there. And this one is there. Here it's quad flat
Yeah.
pack.
Yeah, that is an FTDI.
It's an FTDI chip. Yeah, it's a very
Chip.
nice FTDI chip. Read all about it. And how to use this drag method. Well, the drag method is a method where you. We saw that in yeah.
Yeah.
As you can see here, I think I have my. Yeah. The trick is to apply lots of flux on the surface. Place the board So put a lot of flux on the board. Place the component on the right place. Make sure when you're designing this that you have enough copper on these sides, because otherwise it's not really done quite right.
Yeah,
it's
we have
very
an
hard to do.
example actually. I don't know if Patrick can show that, for instance, but I mean, if the pads are slightly bigger,
Yeah.
then let's see. You see this component here, the pulse thing. You see it's slightly turned down or something like that. It's, I mean, if the pads were smaller,
Yeah.
then you would have a problem, because the contacts will not, you know, probably properly done.
Yeah.
So it works because the pads are big enough, and even though the component is slightly turned down
Yeah.
on one side, the contacts
Are good.
are good.
Yeah,
Exactly.
contacts are good. This happens when you have a. This is done in an SMD oven, or an SMD reflow oven, and when you at first the chip is floating on the bubble of solder, because you apply
Soldering paste.
soldering paste with a stencil, and it just starts to float, and then it tends to shift quite
Like surfing.
Yeah.
Or
So if you're doing production for SMD, then you have to then you don't have to make the parts bigger. Actually, you shouldn't, because when there's room to shift, it will shift.
yeah.
So it's all in designing on this one, and what for do you design it? But if you're designing it for your own to make maybe 5 or 10 pieces, then it's much easier to spread a bit more with the
pad
solder
size,
pads,
yeah.
make the pad size a bit bigger. Then you can use the drag method to do so. And the drag method is a method you apply lots of flux here, and then you load on a fairly large tip. You load the solder in it, and you just start on this side and drag down from there till there. Drag down, heating up in a special way, heating up the parts and the leads, and then the capillarity of due to the flux and the capillarity of the flux between the paths and the islands and the solder leads, it tends to pull the solder out of it. There's also a special tip. It's a very special technique. You have to get used to, if you have one tip, then you have to get used to the amount of solder you put on. If you have too much solder, which in the question of Steve I understood, he had some problems with the first two. It is due to the amount of solder you have on. And that's not a problem, because you can correct that. You can just apply again the iron on it and just put it.
Yeah.
So you can divide.
Try to make the solder to go to the
to
tip
the right side
of the soldering iron.
But do apply some flux, because otherwise you will be smoking up the solder pads. So there are quite a few. Also, don't try to do 4 sides together. So don't load your soldering iron.
Yeah, and keep on going.
And keep on going. No,
on all the sides.
one side at a time. One side at a time. And to prevent your component from shifting, you can use the method with the Kapton tape. There's also another method to do it, and that involves
Glue?
the glue.
Well,
Glue. Surface mount adhesive. We have here another tube, because we use it also. Don't know if it's so there are also several manufacturers to do so. These are the two we have here, but you can just bond it to the surface of the PCB, so it doesn't shift. You have to wait a few minutes to let it stick.
Yeah.
But
why I cannot use, for instance, super glue or whatever?
because super glue, if you're heating up, for instance, to 200 degrees, then super glue will be very poisonous.
Yeah.
The fumes that will come out of your SMD oven or out of your hot air handgun, the fumes, you'll have problems. I think probably, I didn't test that, for instance, but I test everything I can lay my hands on, but I didn't test that. I think when you have the fumes in your face of this cyanoacrylate, cyanoacrylate glue, then there's a chance that your eyes is going to do this, and you'll not be able to open them.
Back.
So don't use super glue. No, it's not a good thing.
Advisable. Okay.
It's not advisable.
Good to know.
I would say don't try this at home. Okay, we have there's a few
things
things that you have to consider by this drag method. Prevent bridging. He had some issues with it. We have a nice.
I think it's here.
We have a nice tip. I think it's this one.
Is you?
No, it's this one. We have so many tips here that it's hard to find.
Perhaps, our cameraman can zoom, because this is interesting to see.
Don't know if you can see it like this.
Yeah.
I'll turn it around. Yeah.
Exactly, yeah. So that looks like a spoon to me.
It is actually a small spoon. And it's not quite a spoon, but it's a hole where you can load.
Like a pen. Like a pen with ink.
Like an old school pen. You can load your solder on it. Like this.
Yeah, let me just take this out.
Yeah.
So it can be seen better.
Yeah. You have to shift to this side here.
Yeah,
so
perfect.
you can load your solder in it like this, and then if you have your solder on it, you just
You need any board will do.
Any board will do. You just drag along. And you have to experiment with the angle that you put the iron on. Sometimes it works best if you do like this. There will be less flow of less amount of solder, and sometimes if you on the side that's already a bit when the solder has come out, so you don't have that much solder on your spoon. Then you have to maybe we tend to bend it over a bit.
So you can slightly control the amount of solder that is going out the spoon, so to say, to the pins.
To the pins. Also, you have to experiment with the amount of solder that you put on, because when you have only 12 or 8 pins on one side, you have to have a lot less solder than when you have 24 pins or 20 pins on one side. So you have to experiment with that. It takes a certain technique. It takes a lot of experience to do that. We try that, and I can do that, but I have almost 41 years of experience in soldering. So, but if you have good examples, please send us pictures or films about it, or little movies. We're always keen to show this to other readers of our magazine and of our website. Then another thing is that you have to apply lots of flux. Lots of flux. So don't be too poor on the flux, because the flux is used to let it flow, it flow, but also to get the heat a bit away from the components that you don't want to heat up that much. So you'll be having contact with your iron and with your pots and with your leads, but the other parts shouldn't be heating up that much. That's a technique in contact soldering. So apply a lot of flux, lots of flux.
Even though this kind of soldering wire is cored, right?
It's
cored.
Yes,
Flux on the inside.
It's cored, yes. We also will get back to that later. I think I have a nice picture of that too. Yeah.
Okay.
Okay. Steve had also an issue which could be caused by the tip of the solder iron. If you have a tip of the solder iron, it can be oxidized when you use it quite a lot, then it will not, if you use it every day, it will not be that oxidized. But what happens with people who don't do that much soldering at home, so you're 3 weeks busy of designing and making a PCB, and then at some point you get your PCB design ready, you make your PCB, or you let your PCB be made by a manufacturer, by yours.
You wait until it's coming and
yeah,
arriving.
and then you have it there, but there are always 2 or 3 weeks in between. In this time you don't use your soldering iron, so it can be oxidized. And what happens then? It's similar. Your solder doesn't stick. Well, all kinds of things can go wrong.
Because there's a layer of
there's an
rust.
oxidized layer. Yeah, it's not quite rust, but it's an oxidized layer. And what you can do, before, if you have even if you have a tip like this, then just there are special. This is special. This is gold actually. It's gold cloth, and or gold. It's gold plated.
Yeah.
And then you rinse it and you cleanse it very good. If you have this one, it's all easier to cleanse, but put it in there and then apply lots of flux on it, and it will be good. So sometimes it's not that you only can use the spoon, the sponge, because we have a sponge on it, but you have to really cleanse it. Another thing that can be happening is your solder feed is too fast. If you're dragging it along too fast, then the solder doesn't get time to go capillary underneath the soldering leads.
So the feed for everybody to know is basically, I mean, the force you're pushing your soldering wire, right?
You can have different techniques, because if you use a spoon type like this, then you just fill it
exactly
up front
before
and make your drag soldering. If you have a normal iron, then you have to, there's another technique. You can just, see if we can show this here. This is very keen, it's not easy, because this is a technique that you put your soldering iron here, and you let your soldering...
not on the tip,
no,
you mean, but
yeah,
slightly above the tip.
Yeah, slightly above the tip. It's very easy to have too much soldering wire on it. So that this gets melted off and it's melted down, and then you have to drag this. So you have to...
Wait, now you can do it.
You have to fill the iron with that. But that's a technique, even I do not master that perfectly. So if you can use a spoon, that's better. Spoon tip like. The iron speed, if you're dragging it along too fast, actually it's the same. Either you are feeding the solder wire too fast, so then you get a lot of soldering on places you don't want. Your iron speed gets pulled down too fast. And there's another issue. We have the lead-free and the lead solder, and the lead-free solder that clings. So it has a different viscosity than the other one. So if you're doing this drag method, my advice is to keep it to a traditional lead-free solder wire. We showed you just the special tools of this. So I hope, Steve, that this answers your question.
Okay, and Peter Bukens, he's asking about flux soldering. Okay, so
yeah. Well, I asked my colleagues, but only with flux soldering. I think he means, because that was the only information that we have from him. Maybe he is attending now. He can enlighten us a bit about what he means. But he only wrote flux soldering in his question, so it's a bit. We are not sure what he is referring to. Flux is used, of course. It is in tiny pots, and it is in a pen. It's used. It's in this syringe. What we use. And of course, it is in every. You can see it here on this side. Here,
Ah, that's the picture you tell. Yeah, that
That's-
was the core
yeah.
of the wire.
Yeah, this is only this is a pen with flux in it, and there are all kinds of different resins, rosins, and all kinds of different flux. The only thing you have to take care of is that you, for electronics, you don't use a flux that is used to solder, for instance, copper pipes or copper heating pipes or water pipes at home, because it's very, very corrosive. That means when you solder it, when you put flux of this kind on it, it's S65, I know it's S39, I know, then perhaps you can get your PCB, your project to work one time, two times, but if you pick it up after a week or two, then you can see a green smudge all over it, and it starts eating up the copper surface.
Okay.
So
It's
after
completely
a few
corroded,
weeks,
or-
it's completely gone.
Yeah,
It's so aggressive, so don't use that. Just use the fluxes, the resins that you have here. The pen, we have a pen downstairs, but I couldn't find it yet, but we have that downstairs. And of course, every solder wire you have here, every solder wire we have here, there's flux in it. So when we are normally through hole soldering, we don't have to use additional flux because it's in the wire.
Yeah.
So
it's actually the smoke you see is the flux.
the smoke
Of
you
course.
see is a flux.
It's not
building up.
it's not the metal.
No, it's not the metal. No, it's not the metal.
So, yeah.
If your metal is melting down, then you should turn to your soldering wire, to a soldering station, because it's far too hot. But so there's all kinds of flux involved, and then well, all kinds of.
Okay. Yeah. Now you can. Yeah.
Okay, we had another question from
from-
Dr. Raya Sekharayappa. I hope I pronounced it well. And it was about dip soldering methods and machine. What we see here on the picture is
A robotic arm.
a robotic arm, and it's used to actually to solder the tip. Some kinds are just programmed to do so. So you have a file, a G-code file, to where to put the soldering point. And others have other of these robot machines have a technique that you have a small arm, and then you just you learn it to the machine one time. You learn it to the machine one time, and then the machine picks it up, and then it's the same technique as is used in automotive industry. For instance, for spray painting or for welding, they just one operator does it one time or two times or three times until he has it perfect, and then the machine learns from it, and he stores it, and the machine does it.
Implements the same action.
Implements the same action. So that's robot soldering. That's one machine. He has also asked about dip soldering machines, and dip soldering is the technique. You have a bath, a melting bath. First, there's
Full of solder, like a
Yeah.
bath.
full of solder, and the PCB and the components that you see here just get dipped, not drowned in it, but just dipped. Just the surface of it get dipped in the
bath?
in the bath, in the solder bath. And the solder bath is of course heated to the melting temperature of the mixture, and it's just put in a few seconds and taken out. Of course, before this has happened, before this, there is a flux bath or a flux roller that puts flux on
And the board is like rolling over
Yeah.
the flux.
And of course, the pins of these leads are shorted.
Perhaps, yeah.
Yeah. So that's dip soldering. And as you can see here, then it gets dipped for a few seconds. Then it's just pulled out.
Taken out. And the solder gets like absorbed by the pins themselves. Okay, and it gets there.
And also we have here wave soldering. And with wave soldering, there's a kind of, well, you also have different machines that do that. But in this case, it's a conveyor belt. And a spray fuser sprays flux on
yeah, on the back.
on the back of the PCB, on the soldering side.
side or,
Then you have preheaters, and they preheat the PCB, and then the PCB goes over a wave solder. So there's a dipper in it, and it takes a wave, or it gets sprayed up. It's heated 300 degrees, and it's heated and gets sprayed up like that. And then, of course, it cools down on this stage.
So only the crest of the wave is touching the PCB.
Yeah,
so to
that's
say.
right. So
like surfing.
it's also not completely drowned in it, but it's only the downside of the PCB.
Yeah.
Is going into the wave.
Yeah. Okay.
Yeah. We have 2 questions for next time, because I see we're running slightly out of time.
Running out of time.
We have to also do something. And 2 questions for next time. SMD soldering, and we had a question about BGA to PCB.
Yeah.
BGA is being a ball grid array. You see it here.
That's tricky. Yeah, we brought for you to know, guys. BGA, how a BGA looks like. Here's a Raspberry Pi. Oh, sorry. Yeah. And that one, you see this one, this chip here.
No leads at any side.
No, you don't see anything actually. Well, if you, most probably you have a Raspberry Pi at home, so you can check it. And it's like this is, to me, this is impossible to.
Yeah, it's not impossible. We'll see that.
Yeah.
We also have some experts from Arcos, and if they're not joining now, I hope they can join us next time. We'll send them an invitation. They know a lot about it, and they can also X-ray these
and check. Yeah.
So that was my story for this time.